Ever get the feeling that some software is just like, well, one giant unmovable thing? You know what I mean?
Oh,
You
absolutely.
want to make an update and it takes forever, or you're trying to handle like a bunch more users and it feels like you're pushing a boulder uphill.
Yeah, yeah. It's like trying to turn a cruise ship on a dime.
Exactly. But there's this different approach that's gaining a lot of traction, and that's building applications with what they call microservices, like a bunch of
Mhm.
smaller, faster pieces.
Right, right.
So today we're going deep on what makes those microservices tick.
Absolutely. And we've got our resources all laid out. And for this deep dive, our main guide is the book Spring Microservices by Rajesh RV. It's from 2016.
Okay. Yeah.
And think of this like your express lane, to understanding the core of microservices.
Perfect. So whether someone's out there like prepping for a big meeting or just, curious about this whole architectural style, we're going to pull out the most essential insights from the book.
Yeah, we want to give you those aha moments.
Exactly. Without making it feel like you're drowning in technical jargon.
No, no, no. We'll keep it nice and clear. So we'll be talking about what microservices are, the real benefits they offer, the big design choices you'll face, the challenges, and how they relate to technologies like Docker and Spring Cloud. Sounds good.
Sounds great. So let's start with the basics. What exactly is a microservice?
Okay, so picture this giant software application.
Okay.
Instead of this like one massive block of code, you break it down into a team of specialists.
Okay, I like that.
Each specialist, each microservice handles a specific business function totally independently.
So it's like instead of one Swiss Army knife that does everything kind of okay,
Right.
you have a set of specialized tools that are each really good at their one job.
Yes, exactly. Each one's a master of its craft. And these specialists have certain, key characteristics. One is service abstraction. And it's not just about hiding the complexity. It's
Yeah.
like completely separating the services environment, and the technology it's built on.
Oh, I see.
Think of it like each tool having its own dedicated power supply and instruction manual. Totally isolated.
Okay. So it's like each one operates in its own little world, basically.
Exactly. Then you have service reuse. These aren't like one-time use functions, right?
Got it.
They're designed to be more substantial business services, accessible from different channels, like your mobile app, the website, even other microservices, or totally different systems.
Oh, interesting. So they're very reusable.
Yeah, very versatile. Then there's statelessness. Now, ideally, a well-designed microservice, it doesn't hold on to any past interactions.
Hmm.
Every request is treated as brand new.
Okay.
If it needs to remember something, that info is stored externally, maybe a database or a cache. This statelessness, it's crucial for easy scaling.
I see. That makes sense.
Yeah.
So then how do all these independent services work together? How do they even know about each other?
They need to be discoverable. They basically announce themselves.
So they're like, hey, I'm over here. I do this.
Exactly. And if a service goes down, it automatically takes itself off the map. It's a very dynamic system.
But they're pretty self-aware.
Very much so.
Right.
And finally, there's service interoperability. Microservices talk using standard protocols like the common language of the internet,
Makes sense.
HTTP, REST, JSON. For speed and efficiency, you might bump into things like protocol buffers or thrift.
Okay.
But those can sometimes be trickier to integrate with other systems.
Right. I get it. So we have these independent, chatty, self-aware services. What's the payoff? Why is this style of architecture so appealing?
Oh, there are tons of advantages. One is the polyglot architecture. You're not stuck with one tech stack.
Oh, right.
You pick the perfect language, framework, database for each service. It's like having the right tool for the job.
That's so flexible. And what about innovation? Does this architecture help with that?
It absolutely does. It encourages experimentation. Because the services are smaller, you can try new things without risking the whole system.
It's like running these contained experiments.
Yes. If something fails, the damage is limited.
So it's like a much safer way to try new things out.
Exactly. Microservices also allow for elastic and selective scaling. Different parts of an application, they often have different demands.
Right.
With a monolith, you got to scale the whole thing, even if only one part is super busy. It's inefficient.
And with microservices.
You scale individual services up or down as needed.
So like if the login service is getting hammered.
You just scale that one. Super efficient use of resources.
It's cost effective too, right?
Oh, absolutely. Then there's substitution. Because each service is independent, you can replace or upgrade them without impacting the rest. It's like swapping out a single component in a machine.
That's much less disruptive. Now, the book mentions building organic systems. What does that mean?
It means the system can kind of grow more naturally,
Got it.
adding new services or modifying existing ones without this big coordinated effort.
Ah, I see. So it can evolve more smoothly.
Exactly. And it helps reduce that scary technology debt.
Oh, right. Instead of this giant overhaul.
Yeah, you can update or rewrite individual microservices piece by piece with newer technologies.
Much more manageable.
Much less stressful.
Yeah.
And then you can have different versions of a service running at the same time.
How does that work?
Because they package their own dependencies, you avoid those conflicts you get with monoliths. It's key for things like zero downtime deployments and canary releases.
Oh, right, where you roll out a new version to just a few users first, right?
Exactly. And the book also highlights that microservices are great for building self-organizing systems. They can discover each other and interact more dynamically.
So it's like they can adapt to changes more easily.
Exactly. And it supports event-driven architecture where services communicate through events.
So it's less about direct commands and more about reacting to changes.
Yeah, it leads to looser coupling, more responsive and resilient systems. And finally, microservices are a big enabler for DevOps. Their independent nature just fits so well with automation.
Makes sense. So microservices sound like a real step forward. Now, we often hear SOA, service-oriented architecture, mentioned in these discussions. Are they the same thing?
That's an important distinction. The book talks about a few ways people have used SOA. One is service-oriented integration, or SOI, often involved a central enterprise service bus, or ESB.
So everything had to go through the central hub.
Yeah, kind of like a central nervous system. Microservices are much more decentralized.
Okay. And then there's using SOA for modernizing legacy apps.
Right. Another common use was to create service layers on top of old systems. They would often use ESB adapters to connect.
Still very reliant on the ESB.
Yes. And then there's the concept of a service-oriented application.
Okay, what's that?
Some organizations adopted SOA ideas within their monolithic apps using lightweight frameworks like Apache Camel or Spring integration. The book suggests microservices are like the next logical step, taking those smaller integrated services and making them truly independent.
Oh, that makes the relationship clearer. The book also mentions the 12-factor app. What is that exactly?
It's like a set of best practices, popularized by Heroku, for building modern, cloud-native applications. It's a blueprint for applications that are robust, scalable, easy to deploy, and manage in the cloud.
So how do those principles apply to building microservices?
They're incredibly relevant. Actually, the book argues they're equally important.
Wow.
Things like maintaining a single code base, clearly declaring dependencies, configuring through environment variables, treating backing services as attached resources, all of that aligns perfectly with microservices.
So it's like a perfect match.
Pretty much.
Yeah.
The book specifically emphasizes stateless, shared nothing processes, crucial for fault tolerance and scalability.
Right.
If a microservice doesn't remember client-specific stuff between requests, it's easier to spin up new instances to handle more traffic.
So if one instance fails.
Another one can take over seamlessly. No data loss, because there's no session data tied to a specific instance.
Got it. And what about exposing services through port bindings?
That's about making the microservice self-contained. It embeds its own HTTP listener instead of relying on an external web server.
So it's more independent and easier to deploy anywhere.
You got it. Now, when does it really make sense to use microservices?
Right. When is it the best fit?
The book points out a few key scenarios, like migrating a giant monolithic application,
Okay.
to make it more scalable, manageable, improve development speed, and release cycles. Also, if you have a legacy application nearing its end of life, microservices offer a way to rewrite it gradually, piece by piece.
So you're not doing this huge, risky overhaul all at once.
Exactly. And applications where different parts need different technologies, those are great for microservices.
Right. So you have the flexibility to use the best tool for each job.
Exactly. And finally, apps that could benefit from the CQRS pattern that separates reads and writes for better performance.
Okay.
Those often lend themselves well to a microservices approach.
That makes sense. Now, on the flip side, are there times when microservices might not be the best solution?
The book mentions one situation in particular. It's when an organization has policies mandating the use of a central ESB for, core business logic.
Oh, I see.
That clashes with the whole decentralized nature of microservices.
Right. You'd have to make some big policy changes first.
Exactly. So we've talked about the what and the why of microservices.
Right.
Now let's dive into the how. What are some key concepts when you're designing and building a microservices system?
Okay, let's get into it.
One fundamental thing is how these independent services actually talk to each other.
Right.
They can communicate synchronously, like a request response, or asynchronously, which is more like fire and forget.
What are the pros and cons of each?
Synchronous communication is stateless, good for availability. Errors are immediate, but it can also lead to tighter coupling.
So one service is waiting for another to respond.
Yeah, and it's dependent on its availability and speed. With asynchronous, services exchange messages without waiting, looser coupling, better resilience, but it can be harder to track the flow of events and manage errors.
Interesting. The book also talks about choreography.
Right, where services react to events broadcast by others without a central conductor. Very decentralized.
So it's like a more free-flowing system. Another question I had is about granularity. How many endpoints should a single microservice have?
It's a balancing act. Take a notification service.
Okay.
If you have very different types of notifications, you might split them into separate services.
Right.
But for something like a loyalty point service, with earning, redeeming, transferring, keeping those together might be better. Depends on how closely they share data.
Makes sense. So it's about finding the right balance.
Exactly. Not too many, not too few. What about rules engines? Centralized or embedded?
Ooh, good question.
A central engine lets you manage rules in one place, but it creates a dependency. If the rules are simple and specific to one service, embedding them might be easier.
Right.
For complex cases, a central repository with maybe local execution within each service could work.
So there are trade-offs to consider.
Yeah.
What about BPM systems and workflows? Where do they fit in?
BPM systems can be orchestrators, They use headless microservices to implement complex business processes.
Okay.
They can also monitor the flow of events in those decentralized systems we talked about.
So they're like the overseers.
In a way, yes. They make sure everything is running smoothly.
Now let's talk about data. Can microservices share a database?
Big no-no. To stay independent, each one should have its own data store. It prevents tight coupling and lets each service choose the best database for the job.
That makes sense. But what about transactions that span multiple services? How do you ensure data consistency?
The idea is to stick with local transactions within each microservice.
Okay.
Distributed transactions, where you try to coordinate changes across multiple systems.
Yeah.
These are generally discouraged. They're complex and can impact performance.
The book uses the example of the tour reservation and the wheelchair request.
Right, to show how easy it is to get inconsistencies with simple event-driven updates. The best approach is often to try to contain transactions within a single service.
So rethink the process itself.
Exactly. Now, what about shared reference data, like country codes or currencies?
Ah, yes, that's a good one.
The book offers a few options. Hard coding for truly static data.
Okay.
A dedicated microservice for that data, but that can mean lots of calls.
Right.
Replicating the data in each microservice, but then you have to keep them in sync.
Yeah, that could be a pain.
And finally, the preferred approach, according to the book, is a local near cache.
So each service has its own little copy that it can update as needed.
Exactly. Then there's handling bulk operations, which can be tricky.
How so?
You can't do joins across different microservice databases.
Oh, right.
So to get a bunch of records, a service might need to make a ton of individual calls to other services.
Oh, wow. That doesn't sound very efficient.
It can definitely impact performance.
So moving on to service endpoint design, what are some key principles to keep in mind when designing how clients will talk to our microservices?
First off, you need a clear contract.
Okay.
Well-defined interfaces that specify how services interact. And then there's protocol selection.
Right, how they'll actually communicate.
HTTP, REST, and JSON are the most popular for their interoperability, but there are others you might consider depending on your needs. The book also mentions HDOAs.
Oh, yeah. What's that about?
It's a way to let clients discover the API more dynamically using links in responses.
Interesting. What about shared code?
Sharing libraries can reduce duplication, but it also creates coupling.
Right. A change in one place could break things elsewhere.
Exactly. So you need good versioning and dependency management if you go that route.
Makes sense. Now, what about user interfaces? How do those fit in?
There are a few approaches. Full-stack microservices, where each service owns its own UI. Or API gateways, which aggregate data from multiple services for the front end.
Speaking of API gateways, we've mentioned them a few times. Can you remind me of their main purpose?
Sure. They're the entry point for external requests. They hide the complexity of the backend.
Okay.
They can route requests to the right services, transform data to match what the client needs, and handle things like authentication and authorization.
So they're like the traffic cops and security guards of the microservices world.
Pretty much. Now, the book touches on ESB and IPS, again, in the context of endpoint design.
Are those still relevant for microservices?
Traditional ESBs, they're often too centralized for microservices.
Right.
IPIS, which is more cloud-focused, might be useful for certain integrations, but generally, communication in a microservices architecture is more direct.
Got it. What about service versioning? How do you manage changes to APIs without breaking existing clients?
The book talks about URI versioning, media type versioning, and using custom headers. And with URIs, it's common to have an alias for the latest version.
Oh, so you don't always have to specify the version number.
Exactly. And lastly, for web browsers accessing your microservices, you need CORS. It allows requests from specific domains where your web apps are hosted. It's a security thing.
So you can control who's allowed to talk to your APIs. This all paints a clear picture of the design landscape. But what about the challenges?
Moving to a distributed system definitely has its complexities.
Like what?
Data silos are a big one. Data is spread across multiple services, making it harder to get a complete view.
Right. And I imagine logging and monitoring must be more difficult.
Absolutely. Tracing a request as it goes through multiple services can be a nightmare.
Yeah, you don't have that one central log anymore.
Nope. And managing dependencies becomes super important. You got to track how services rely on each other and ensure they're compatible.
So what about the people side of things? Does the team's way of working need to change?
Oh, for sure. It usually means closer collaboration between development and operations.
Or more of a DevOps culture?
Exactly. Governance can be trickier in this decentralized world too, and there's more operational overhead.
Right. You have many more things to deploy and manage.
Yeah, potentially hundreds of containers or VMs. And testing gets more complex.
In what way?
You have to test each service individually and how they interact with each other.
Oh, I see. So it's a whole different level of testing.
Definitely. And infrastructure provisioning needs to be automated to keep up with the dynamic nature of microservices.
So to manage all this effectively, what kind of capabilities and infrastructure do you need?
The book lays out a microservices capability model.
Okay.
It starts with core capabilities, like the ability for services to listen for requests, a well-defined API gateway, and user interfaces. Those are the basics.
The things users and other systems directly interact with.
Exactly. Then there are the infrastructure capabilities. Things like service discovery, routing, load balancing, cluster control, and application lifecycle management. The behind-the-scenes stuff that keeps everything humming.
So it's like the nervous system and circulatory system of the microservices world.
You got it. Then you have supporting capabilities like security services, a central config server, and monitoring and logging systems.
Those are critical.
Absolutely. And finally, process and governance capabilities. Things like DevOps tools, a microservice repository, documentation, a reference architecture, all that good stuff.
So it's not just about the technology, it's about how you work as a team too.
Precisely. Now, the book uses a case study of Brownfield Airlines' passenger service system to bring these concepts to life.
Oh, interesting. Tell me more about that.
They started with a monolithic PSS application, one big app handling everything from ticket sales to check-in.
Okay, so a classic monolith.
Yeah. At first, they had separate clusters for the web interface and business logic. They could scale horizontally, even had zero downtime deployments.
Sounds like a well-designed monolith, at least initially. So what challenges did they hit?
They ran into performance problems, especially during peak times.
Oh, that's not good.
They tried y-axis scaling, deploying the whole app in multiple clusters.
Okay.
But their database became a bottleneck. They then implemented Oracle RAC, which helped, but added complexity and cost. And they ended up with a ton of tech debt. They realized they needed a complete rewrite.
So even a well-structured monolith couldn't keep up in the long run.
Right. The book points to shared data as a major issue. Almost every part of the app needed the same core data, like airport codes and schedules.
So they were tied to this one big database.
Yep. And their solution was to move to microservices.
Yes. What were their main goals with that transition?
They wanted an architecture aligned with their business capabilities, where each microservice owns its data, logic, and even its presentation layer.
Wow, so a much more distributed model. How do they go about actually identifying which microservices to create?
They started with functional decomposition, analyzing the monolith, and looking for potential boundaries between business functions. But they knew that was just a starting point.
Right.
They needed to figure out how those potential services would depend on each other.
So dependency analysis was the next step.
Exactly. And their initial analysis revealed a lot of tight coupling, a real mess of synchronous calls.
That sounds familiar. It's like untangling a giant knot.
Yes. So they had to figure out how to reduce those dependencies.
How do they go about doing that?
They looked at switching from synchronous to asynchronous communication, where services wouldn't be blocked waiting for each other. They also combined query-based approaches, where a service requests a snapshot of data with event subscriptions for ongoing updates.
So it's not always about one service directly calling another.
Right. They had to rethink how information flowed between different parts of the system.
The book has that example of the check-in service needing booking details.
Exactly. Instead of a direct call, the check-in service queries for booking details and subscribes to events about changes.
Interesting. So they're decoupled, but still get the info they need.
Yes. And they had to think carefully about grouping services.
Right. Not everything becomes its own microservice.
Their initial idea was to group search, inventory, and booking together.
Okay.
But they realized those have different scalability needs. Keeping them together could lead to overscaling.
Right, because a surge in searches shouldn't affect the booking process.
Exactly. They also had to prioritize which services to migrate first.
So how did they decide that?
They focused on business-critical services and those that changed frequently.
The ones with high change velocity, as the book puts it.
Yes. So booking and check-in were high priority. Search, booking, and fares were also prioritized because they changed a lot.
So those would benefit most from the agility of a microservices architecture.
Precisely. And then there's data synchronization during the transition.
Right. How do you keep the old and new systems in sync?
The book says to avoid direct database synchronization, it breaks the whole idea of independent data ownership.
Yeah.
They recommended UI-level integration or building new shared services that both the old and new systems can use.
Like a new authentication service, for example.
Exactly. They also had to figure out what to do with the user interfaces during the transition. They considered separate UIs, the legacy UI redirecting to the new one for certain features, and directly integrating the new services into the old UI.
So many options to consider.
Oh, right. In the end, they built a new identity store and authentication service that both old and new UIs could use.
So it's a phased approach, slowly building out the new system.
Exactly. Now, the book then dives into how they scaled these microservices using Spring Cloud.
Ah, yes. Spring Cloud. Tell me more about that.
Spring Cloud is like a toolbox built on Spring Boot. It gives you everything you need to develop and run microservices at scale, especially in the cloud.
So it tackles those complexities we talked about.
Yep. Configuration management, service discovery, routing, load balancing, asynchronous messaging. It's got it all.
Sounds comprehensive.
Mm.
Which specific components of Spring Cloud did they use?
The book focuses on Spring Config Server, Eureka, Zuul, Ribbon, and Spring Cloud Stream.
Let's start with Spring Config Server. Why is externalizing configuration so important?
In traditional Spring Boot apps, config is usually in property files within the app itself.
Right.
But with microservices, you might deploy the same service to different environments, and the config needs to change.
Okay.
If it's baked into the app, you have to rebuild and redeploy every time.
And that defeats the purpose of having a single build artifact.
Exactly. Spring Config Server solves that problem. It's a central repository for all your config settings.
So the services fetch their specific config at runtime.
Yep. They connect to the config server, say who they are and what environment they're in, and it gives them the right settings.
That's so much more efficient. The book also stresses the importance of high availability for the config server itself.
Oh, absolutely. If it goes down, your services can't get their config.
That could bring everything to a halt.
Right. So you need multiple instances and a robust backend store, like a replicated Git repo.
So you can be sure it's always there. What about Netflix, Feign, and Ribbon? What do they do?
Feign makes it easier to do HTTP calls between microservices. You define an interface with annotations describing the API, and Feign takes care of generating the HTTP client code. Much cleaner.
So much nicer than writing all that low-level code yourself.
Right. And Ribbon is for client-side load balancing.
Right, because you might have multiple instances of a service running.
Exactly. Ribbon distributes requests across those instances, improving performance and availability. It works seamlessly with Feign. You make a call to a service registered with Eureka, and Ribbon handles the load balancing automatically.
That brings us to Eureka itself. What's its role?
Eureka is a service registry. It's like a phone book for your microservices.
So they can find each other.
Exactly. Services register themselves with Eureka, telling it their address and other info. Other services can then ask Eureka where to find a specific service.
Dynamically, I assume.
Of course, no more hard-coding addresses. If an IP changes or new instances are added, services can automatically discover those changes.
That's super flexible.
Huh.
The book goes into detail on how to set up Eureka and configure your microservices to use it.
Yep. It even shows how the Brownfield PSS website used Eureka to find and communicate with backend services.
Okay, what about Zuul?
Zuul is the API gateway.
Right, the entry point for external requests.
It sits in front of your microservices, routing requests, handling authentication, rate limiting, monitoring, all that good stuff.
It really simplifies things for the client.
Totally. And because it integrates with Eureka and Ribbon, it can automatically discover and load balance requests to your backend services.
Very cool. Lastly, there's Spring Cloud Stream. What's that all about?
It's for asynchronous communication. It lets you build event-driven microservices without having to deal with the specifics of message brokers.
It's brokers.
Like RabbitMQ or Kafka. You define logical queues, and Spring Cloud Stream binds those to the physical queues in your messaging system.
So it's another abstraction layer to simplify things.
You got it. The book has examples of how Brownfield Airline could use it to decouple their services. So Spring Cloud really gives you the tools you need to tackle the challenges of running microservices at scale.
Absolutely. Beyond those specific technologies, are there any general principles for managing and scaling a microservices environment?
Auto-scaling is key. You need your infrastructure to automatically adjust the number of service instances based on demand.
Right, so if traffic spikes, you can handle it.
Exactly. And when it's quiet, you don't waste resources. It's a big change from traditional clustering where you have a fixed number of servers.
So what are the benefits of auto-scaling?
It makes your system more available and fault-tolerant. If a service instance fails, the system automatically spins up a new one.
Yeah.
And it also means you're only paying for the resources you actually use. Much more efficient.
What are some approaches to auto-scaling?
You can scale at the app level by simply running more copies of your microservice. Or you can scale at the infrastructure level by creating more VMs or containers. The decisions are usually based on resource usage, like CPU and memory, or on demand, like the number of requests.
I see, so you can get very granular with your scaling.
Yeah.
The book also talks about logging and monitoring again.
It's crucial in a distributed system. With potentially hundreds of microservices, you need a centralized way to collect and analyze logs.
Right, you can't just look at individual log files anymore.
Nope. The book talks about traditional file-based logging, centralized logging platforms like the ELK stack, and SaaS solutions.
And then there's distributed tracing.
Yes. You need to be able to trace a request as it jumps between services. Tools like Zipkin and Spring Cloud Sleuth help you do that.
So you can see the whole journey of a request and spot any bottlenecks.
Precisely. And then there's monitoring. You need to understand the health and performance of your services in real time.
And what about handling failures?
Fault tolerance is a must.
Right. Services will fail. That's a given.
Exactly. The book talks about Spring Cloud Hystrix and the circuit breaker pattern.
Remind me how that works.
If a service keeps failing, Hystrix stops sending it requests.
So it doesn't make the problem worse.
Right. It prevents cascading failures and gives the failing service time to recover.
Makes sense. And then there's Docker, which is closely associated with microservices.
Containerization with Docker is a game changer.
Oh, so?
It lets you package a microservice and all its dependencies into a container, a self-contained unit.
Okay.
These containers are lightweight, start up fast, and are very efficient with resources.
So you get consistent